Factor 24x to the fourth minus 3x to the seventh. If we examine this, the two terms are not perfect cubes. They're also not perfect squares. So in this case, we can't use any of the formulas for perfect squares or perfect cubes, at least not from the start. But there is something we can do. If you look at both of these terms, there is a common factor that we can pull out. 24x to the fourth and 3x to the seventh are both divisible by 3x to the fourth, so we can factor out a 3x to the fourth from each of these factors. If we pull out a 3x to the fourth from the first factor, we're left with 8, and then we have minus. If we factor out a 3x to the fourth from the second factor, we're left with x cubed. So we have 3x to the fourth times the quantity 8 minus x cubed. And now if we look at the leftovers, this gives us a difference of 2 cubes, because 8 is 2 cubed and x cubed is x cubed. So keeping the greatest common factor out front, 3x to the fourth, we then use the formula to factor a difference of 2 cubes. So we take the first minus the last, 2 minus x, and then we multiply that by the first one squared, 4, plus the product, 2 times x is 2x, plus the last one squared, x squared is x squared. And now we have our final answer, 3x to the fourth times 2 minus x times 4 plus 2x plus x squared. If you really wanted to, you could rearrange this so that it was in standard form. This one in the middle would look a little awkward in standard form, negative x plus 2. It's not wrong if you put it like that, but usually with things like this, I like to leave it like it is, because having the negative out front just looks a little awkward. So this is a perfectly fine final answer. You could rearrange terms if you want, but I'm going to leave it just like this.